Hi everybody, welcome back. This is Unit 4, Periodic Table for Regents Chemistry, and this is video number 2. Today we're going to talk about this idea of atomic radius and what atomic radius is. Atomic radius is really exactly what it sounds like. It is the radius of an atom. It is the distance from the center of the atom here in the nucleus, here, to the outermost energy level. Right here. So this is atomic radius, okay? It is really the size of the atom. Not the mass, but how wide the atom is. It is officially defined as 1/2 the distance between two adjacent nuclei. Obviously, when we talk about measuring atomic radius, we don't measure it in centimeters or millimeters because atoms are so small we can't see them. We measure it in picometers. Or PM, okay? 1 picometer is actually 10 to the negative 12 meters, okay? So it's a very, very small unit that we're using. Values for atomic radius for different elements are given in reference table S. And these are atomic radii. They are the radii of atoms. They're given in table S. What you have to know not only is the definition of atomic radius, but what happens to atomic radius as you go down and as you go across a row. So let's talk about as you go down a group. Okay? Now, I have the pictures here so you can really infer what's happening. And again, I'm not writing on this page. We have our word bank down here, so you can plug your words up into the word bank. But as you proceed down a group, you can see what happens to the radius. Radius generally increases. The atoms get bigger each time you go down. Okay? I have something to show you that will help you remember that. Okay, I'm back. So as you go down, atomic radius generally increases. And the reason it increases is as you go down, the number of, anyway, I'm back, sorry about that. So as you go down a group, you can see that the atomic radius generally increases. This is because as you go down, you increase the number of occupied energy levels. So everybody in row 1 has 1 energy level. And everybody in row 2 has 2, and everybody in row 3 has 3. So you go from 1 energy level, and then the next element down, you have 2 energy levels, and then the next element down, you have 3 energy levels. So each time you go down a box in the group, you add on a whole energy level. A good analogy to that is this little kid's toy. You know those stackable rings? So imagine this is the outer shell. So this is 1 ring, 2 rings, 3 rings, 4 rings, 5 rings. Every time you go down, you add on a whole energy level, and more shells means a bigger atom, okay? So you increase the number of occupied energy levels, more energy levels means a larger atom. Across a period is not so easy to understand. Across a period, it doesn't really actually make sense. You can see what's happening. You can see as you go across a period, atomic radius generally decreases. They get smaller, which doesn't make sense because as you go across, you go from 3 protons, 4, 5, 6, 7, 8, 9. You get more protons. You get more neutrons, but you're getting smaller. And the reason you're getting smaller, even though you're getting more protons and more neutrons, is because the valence electrons are all in the same shell. But your number of protons in the nucleus attracting them increases, which causes the radii to shrink. So my diagram of that looks something like this. If you think of lithium, here in the nucleus, there are 3 protons. And there are 2 in the first shell and 1 in the second shell. So the radius is here. As you go to the next element in the group, or in the period, there are 4 protons in the nucleus. There are still 2 electrons in the first shell, but this time there's 2 electrons in the outer shell. So the extra proton can attract and pull that valence shell in. So it's almost like each time you go across a box in the row, you get a greater pull, a greater attraction for that valence shell. It's like pulling that valence shell in. and it's shrinking or condensing the atom. We call that a greater nuclear charge. So this idea here that we get more protons in the nucleus attracting the electrons causes the radii to shrink or get smaller is the idea that there is a greater nuclear charge, which is why as you go across, they get smaller. So in general, more shells means a bigger atom. But what if they have the same shells, right? Like in a row. If they have the same shells, less protons is bigger. Less protons, remember, is the smaller atomic number. Okay? So, we'll do a little analogy with this in class tomorrow. We'll finish our periodic table sheets, or at least you'll have most of the class to work on those. And that's it for tonight. Don't forget the final due date for the Marshmallow Lab is tomorrow, and tomorrow is the makeup test for nuclear chemistry. Have a great night, everybody. Bye-bye.